G'day there. Apologies straight up because I've got a bit of a cold at the moment and I would be quite difficult to understand and quite nasally, so apologies for that. Today we're going to be covering 8.4 logarithms. So by the end of this particular little video, you should be able to understand what a logarithm is. You should be able to convert expressions from index form to log form. You should be able to convert from log form back into index form. You should be able to evaluate various logs, and you should also be able to use your CAS calculator to evaluate various logs. Just a reminder again, here we've got the number 8, and I can rewrite that as being 2 times 2 times 2, or in other words as 2 to the power 3. Now when it's written as this 2 to the power 3, we refer to that as being index form, whilst the number 8 itself is just in that standard form. When we've got an index form, 2 to the power 3 equaling 8, we refer to the 2 as being the base and the 3 as being the index or the logarithm. We can reorganize this equation so it's in a log format. So here we've got log of base 2 of the number 8 is equal to 3. So log base 2 of the number 8 is equal to 3. So the way that we think about this is, if we start with a 2, what do we need to raise it to the power of to get an 8? And the answer for that is 3. So 2 to the power 3 equaling 8 is an equivalent statement to saying log base 2 of number 8 is equal to 3. And we use that little bit of knowledge here quite often to rearrange things. I always prefer to have it with numbers. I find that easier to do the conversion, but here's a complete algebraic approach below. So consider this situation. The number 3 raised to the power of 16 is equal to this really massive number. So this means that if you start with number 3 and multiply it by itself 16 times, you'll get that really large number. One other way is to say log base 3 of that massive large number is equal to 16. So what we're really saying is, if we start with the number 3, what do we need to raise it to the power of to get this really large number? And the answer for that is 16. Same thing applies here. 5 to the power of 4 is equivalent to 625. So here it is in index form. That's the standard form. And then I can rewrite this relationship in logarithmic form. So log base 5 of 625 is equal to 4. This means that if I start with a 5 and raise it to the power of 4, I'll get 625. Or another way of putting it would be to say, if I have 5, what do I need to raise it to the power of to give me 625? And the answer for that is 4. You can see, and we spoke about this earlier, that exponentials and logarithms are opposite one another. They undo each other. So in the same way we've got addition and subtraction being opposites and multiplication and division, exponentials and logarithms are opposite. Here we go, problem 1. Write each statements in logarithmic form. So I'm going to be making use of this connection. So 5 squared equals 25. So what I should be able to realise here is that my base is 5, my power is 2, and then the standard form is 25. So there it is. So I'm going to start with 5, so log base 5 of the number 25 is equal to 2. In other words, if I start with a 5, I need to raise it to the power of 2 to get myself a 25. B, 2 to the power of negative 3 equals 1/8. So log base 2, because that's the base 2, log base 2 of 1/8, that's my answer bit, is equal to negative 3. So there I've converted it. Now we start with the logs, and I need to convert it into index form. So I've got, in my first example, log base 2 of 64 equals 6. So my base here is 2. I raise it to the power of 6, and that will equal 64. Same thing here for B. Log base 7 of 1/7 equals negative 1. My base is 7. I raise it to the power of -1, and it will equal 1/7. Here I need to evaluate the logs. And what's my technique? So consider A. I've got log base 4 of 64 is what I have to work out, what it's equal to. I'll just make it equal to x. And then I'll end up solving for x because that's what I'm actually after. Might sound a little bit confusing at the start, but hopefully it'll make sense to you. So my base is 4. I raise it to the power of x, and that should give me a 64. So I've converted it into index form. Now I rewrite that 64 so it has the same base on the left hand side. So 64 is the same thing as 4 to the power of 3. And now finally I equate the power, so x is equal to 3. So now I know that log base 4 of 64 is equal to 3. What do you think about this? Hey, if I start at 4, what do I need to raise it to the power of to get myself 64? B, log base 3 of 9, what's it equivalent to? Well, I make it equal to x, and so now I rewrite it, so it's going to be 3 to the power of x is equal to 9. Rewrite 9 so it's of base 3, so it's 3 squared, equate the powers. Again, straight away what you can do is go, okay, I've got a 3, what do I need to raise it to the power of to get myself a 9? And the answer for that is 2. C, log base of a half of 1 on 32. What's that equivalent to? Well, let's make it equal to x. And obviously, this would be hard to do in your head, where A and B you could do that for, but for this one it's a bit more difficult. So follow the technique. My base is a half. I raise it to the power of x, and that's equal to 1 on 32. I can rewrite this 1 on 32 so it's 1 on 2 to the power of 5. The trick for that is it's actually 32 is the same thing as 2 to the power of 5. So now I have a half to the power of x equals a half to the power of 5. And because of course 1, if I raise that to the power of 5, it's still just 1. And so because the bases are the same, I can equate the powers, and so x is equal to 5. Looking at D now, log base 6 of 1 over 216, and I just make that equal to x. So my base is 6 to the power of x equals 1 on 216. I rewrite 216 so it's 6 to the power of 3, so 1 on 216 is the same thing as 1 over 6 to the power of 3. Now I want the bases to be 6. That's not a base of 6 overall. So what I'm going to do is take that 6 to the top of the fraction and change the power. So that's now 6 to the power of -3. So if 6 to the power of x equals 6 to the power of -3, and again equate the powers, so I have x equaling -3. E, log of 1/5 of 25 equals x. So my base is 1/5. I raise it to the power of x, and that's equivalent to 25. So I rewrite the 25 so it's 5 squared, because you know you're going to be involving some kind of 5 here. On the left hand side, instead of having 1/5, I can rewrite that as being 5 to the power of -1, so I've brought that 5 to the top, and then change the sign of the power of course. And if I multiply through, I'm going to have 5 to the power of -x equals 5 squared, so -x equals 2, just equating the powers. And now, of course, multiplying both sides by -1, I get x equaling -2. So that tells me, of course, log base 1/5 of number 25 is equivalent to -2. Same thing now for f. I've got log base 9 of the number 1 equals x. I've just made it equal to x because that's what I want to evaluate. So the base is 9. 9 to the power of that x is equivalent to 1. So I've got my 9x here. Can I rewrite that 1 so it has the same base as the left-hand side? And we just have to remember our little fact that anything raised to the power of 0 will equal 1. So I can say, alright, instead of 1, let's write 9 to the power of 0. Now on the left-hand side and the right-hand side, I have base 9. I can simply equate the powers now, so x is equal to 0. So what have I just worked out? Log base 9 of the number 1 is equivalent to 0. Alright, so that's how we do everything by hand, but what about the CAS calculator? Oops, one too far. So I've got my CAS calculator here, and with your logs, what you'll see here is on the left-hand side, you've got this exponential e to the x, and you've got this 10 to the x. And in blue, you've got ln, and you've got log. So for most of our cases, we'll be dealing with this log, and this ln means the natural log. So with the natural log, that involves Euler's number. So this is something like log base e, where e is Euler's number of a certain number to evaluate. But we're just going to be dealing with the log part here. So if I'm considering evaluating what log base 3 of number 9 is, then I know that if I've got a base of 3 and I want to get a result of 9, I need to get 3 to the power of 2 to get my 9. So log base 3 of number 9 should give me a 2. But how do I do it on my CAS? So I go Control, and then this button here. I put my base in this box, so base 3 of the number 9. And then go 9, and so this should spit out a 2 for me. And it does. So remembering log base 3 of number 9, I think if I start with a 3, what do I need to raise it to the power of to give me a 9? And the answer for that is a 2. That's how you evaluate it on your CAS.